Hello everyone. Okay, so this is question 7 of the Junior Cycle Higher Level exam. So, this is our coordinate geometry question, but then also it kind of throws in some geometry aspects as well and understandings of like proofs and theorems and converse of statements, etc. So let's start with this. A, B, C, and D are 4 points on the coordinated plane. The points A and B are shown on the coordinated diagram below. Plot and label the points C and D on the same coordinate diagram. Grand. So I need to plot these 2 points. Need to plot C, need to plot D. So C is 8, 4. So I go over to 8 my x-axis and I go up to 4. There it is. There's point C. And point D is 3, 6. So I go to 3 on my x-axis. Go up to 6 here. That is point D. Point C, point D. Gorge. Write the coordinates of point A and B in the spaces below. The coordinates of C and D are already given. So we need to write down A and B. So we need to plot points both over the read points. So A was 1, 1. Because it's 1 on the x-axis, 1 on the y-axis. B, it's 6 on the axis, but minus 1 on the y-axis. So it's going to be 6 minus 1. And that's the first part done there. Easy peasy lemon squeezy. Right. Pauline wants to prove ABCD is actually a square. Answer BI and BII below to show ABCD is a square. So, show that AB is equal to BC. So, we want to prove this line. You get the point, it's not perfect. I want to prove that line from A to B is the same this line from D to C. So you want to prove that they are equal in measure. So we are going to be using, you can do 2 things. You can use Pythagoras' theorem. You can make this like a little right angle triangle, and a right angle triangle, and then use this length here to find hypotenuse. Or we could just use a distance formula, which is just an extension of Pythagoras' theorem. So distance, I'm going to do A, B, it's A, B, B, C. Muchos, sorry. So we want to prove these sides are equal. So, distance AB, that's going to be equal to, so remember the distance formula, square root, x2 minus x1, all to be squared, plus y2 minus y1, all to be squared. So, distance AB is going to be equal to square root of, so this is A is going to be, it's going to be my x1, y1, x2, y2. So let's sub it in. So x2 minus x1, so 6 minus 1, all to be squared, plus minus 1 minus 1, all to be squared. That is going to equal to the square root of 5 squared plus minus 2, all to be squared, which is going to be equal to square root of 25 plus 4, which is square root of 29. So we have the distance AB is equal to square root of 29. And now we're going to do the same thing, but we're going to prove it now for BC. So the length AB is equal to square root of 29. Let's do the distance BC. Boom. So I'm going to fill in my formula here. So I'm just going to let this now. So x1, y1, x2, y2. There's going to be 8 minus 6, all to be squared, plus 4 minus minus 1, all to be squared. It's going to be square root of 2 squared plus 5 squared, because a minus by minus is a plus, so it'll be 4 plus 5, which in turn is going to equal to root 29 as well. So we have indeed proven that AB is equal to BC because they're both equal to root 29. Right, next part here. Without measuring the diagram, show that AB is perpendicular to BC. So remember, perpendicular means they meet at a 90-degree angle. So we want to prove these lines are perpendicular to each other. So I want to prove that's the right angle triangle there. So we could do, what we're best way of doing is, we're best off calculating the slope of the line AB, and then calculating the slope of BC, and then seeing if it's a negative reciprocal of each other, or when they multiply together I get -1. So that's how we prove if two lines are perpendicular. So I'm going to get slope AB. So remember, slope is equal to y2 minus y1 all over x2 minus x1. That is going to be, so for AB here, that is going to be -1 all over 6 minus 1, which is going to be -2 over 5. That's slope of AB. Now, in order for BC to be perpendicular, the slope must equal to then 5 over 2. Positive 5 over 2. So let's see if that is the case. So the slope of BC, that is going to be here 4 minus -1 all over 8 minus 6. So it would be 5 over 2, right? And if we see here, if I multiply them together, so the slope of AB times the slope of BC, if I multiply them together, -2 over 5 times 5 over 2, I get -1. Therefore, it's perpendicular. So they're perpendicular because when I multiply the two slopes together, I get -1, right? Or the just negative reciprocals of each other. So that was a nice, easy peasy question there. Part C now. Kieran makes the following statement. Kieran's statement: every parallelogram is a square. Is Kieran's statement true or false? Justify your answer. Well, every parallelogram is a square. That is false, right? Because a parallelogram can also be a rectangle, right? So justification. So every parallelogram is a square. Not true. Because rectangles are also parallelograms. There you go, easy peasy lemons. It's not true because rectangles are also parallelograms. Write down the converse of Kieran's statement. So the converse of a statement just means you can reverse it, right? So if his statement is every parallelogram is a square, the converse of a statement is every square is a parallelogram. So you're kind of like flipping it, really. So it's like, try to think of another one. But you get the point. It's like, it's flip it around. Like every angles in a triangle add up to 180. Every triangle, and you get the point. I'm going off the cuff here, but the converse of a statement just means you just flip it around. So the converse of a statement is every square is a parallelogram. There you go, easy peasy lemon squeezy. And that was that question. So it was a nice, easy coordinate geometry question. So yeah, and I'll catch you guys for the next one. See you around. Bye.